In this pencast, we're going to be learning about the binomial theorem. So the problem says, use Pascal's triangle and the binomial theorem to determine binomial coefficients. Expand a plus b to the fifth. Alright, so I have Pascal's triangle written out here, and the pattern goes that the Pascal's triangle numbers are actually the coefficients for our expanded binomial. So if we started at the top, we would have the coefficient for a plus b to the 0, which would obviously just be 1. The next row would be a plus b to the 1, and so on, a plus b squared, a plus b to the third, a plus b to the fourth, and then what we have, which is a plus b to the fifth. Alright, so if you ever have to build your own Pascal's triangle, you can start with 1 at the top, and then the numbers below are the sum of the two numbers above them. So like this 2 is the sum of these two 1s. This 3 is the sum of 2 and 1. This 4 is the sum of 1 and 3, and then this 6 is the sum of 3 and 3. Alright, so now that we know that we're in this last row of Pascal's triangle right here, we should be able to go ahead and write our expanded polynomial. The thing is, you already have to know what the exponents are. So you know that the first exponent is going to be a to the fifth, b to the 0. And we know that the coefficient is going to be 1, since that's our first coefficient. The next one is going to be 5, since that's our next one in Pascal's triangle. And we're going to have a to the fourth, b to the first. So the exponents of a are going to be decreasing as the exponents of b increase. So our next coefficient is going to be 10. We're going to have a to the third, b squared. And then we're going to have 10 again, a squared, b to the third. Then we're going to have 5, a to the 1, b to the fourth. And we're going to end with 1, a to the 0, b to the fifth. Alright, so as you can see, those coefficients correspond with that last row of Pascal's triangle. So based on that, they wrote the binomial theorem, which says, if n is a natural number, then a plus b to the n is basically the summation from k equals 0 to n of n factorial over k factorial, n minus k factorial, times a to the n minus k, b to the k. Alright, so now we're going to write the same binomial using the binomial theorem. So we start out with n equals 5 and k equals 0. Alright, so that means that we have n factorial, so 5 factorial over 0 factorial, 5 minus 0 factorial, a to the 5 minus 0, b to the 0. So that's going to give us our first term, which we already know the coefficient of our first term is always going to be 1. So 1a to the fifth, b to the 0. Alright, so now we move on to k equals 1. So we have 5 factorial over 1 factorial, 5 minus 1 factorial. And then we have a to the 5 minus 1, b to the 1. Alright, so if you don't remember how to simplify factorials, this is going to turn into 5 times 4 times 3 times 2 times 1, all over 1 times 4 times 3 times 2 times 1. So as you can see, all of these cancel out and we're left with just 5. So our next term is going to be 5a to the fourth, b to the 1. Alright, so if we continue on with k equals 2, we're going to end up with 5 factorial over 2 factorial, 5 minus 2, factorial, a to the 5 minus 2, b squared. So if you simplify that, you're going to end up with 10a to the third b squared. Alright, so for k equals 3, we have 5 factorial over 3 factorial, 5 minus 3 factorial, a to the 5 minus 3, b to the third, which is equal to 10a squared b to the third. Okay, and then we have k equals 4. So we have 5 factorial over 4 factorial, 5 minus 4 factorial, a to the 5 minus 4, b to the fourth, which is going to be 5a to the first, b to the fourth. And then obviously we already know that our last term, when k equals 5, is going to be 1a to the 0, b to the fifth. Alright, so if we combine all of those terms, we have 1a to the fifth, b to the 0, plus 5a to the fourth, b to the 1, plus 10a cubed b squared, plus 10a squared b cubed, plus 5a to the 1, b to the fourth, sorry I'm running out of space, plus 1a to the 0, b to the fifth. So as you can see, that's the same thing we got when we used Pascal's triangle. So the binomial theorem allows us to find both the coefficients and the exponents for the terms.